This episode of the Pumps and Systems podcast is brought to you by SEPCO, fluid sealing solutions for every application. All right, then, shall we get started?
Let's go.
Okay.
You did the podcast voice, so I guess I need to.
Oh yeah, no, you don't feel like you need to do a podcast voice. Hello and welcome to the Pumps and Systems podcast. I'm your host, Tom Baer, managing editor of Pumps and Systems magazine. Today, we're going to be joined by Cody Kaufmann from SEPCO, who is going to be talking to us about bioplastics and their role in the future of both the industry and the world as a whole. And please remember to like and subscribe to the podcast if you'd like to hear more from the world of pumps and systems. And feel free to drop us a comment with your thoughts on this topic or suggestions for future episodes. And without any further ado, let's get to the episode. All right. So first of all, welcome to the Pumps and System podcast. And thank you very much for joining us. So how is your day going so far?
Wonderful. Just absolutely wonderful. It's hot here in Texas, but other than that, other than not melting today, I mean, it's good so far.
That's good. Yeah, and in solidarity, Chicago is also in the middle of a heat wave. So
Wow.
yeah.
I mean, I don't want to burst your bubble here, but
Hmm.
your heat wave is a little different than my heat wave. Okay, so
Probably.
just keep your complaining to yourself. Okay?
No, I mean, I can't complain too much because up until before yesterday and today, it was like 70 degrees. And today and yesterday, it's been like 100 degrees with 90% humidity.
Yeah,
But tomorrow
that's hot.
we're back to 70s and 80s. So
Yeah.
I think it's fine.
Yeah, no. And yeah, 100 plus. Okay. I'll give it to you. That's hot. That's hot.
I appreciate that. Yeah. And in the wintertime, you'll be the one who's laughing. So it's all
This is true. Yeah, this is true.
All right, so why don't we start off? If you could start by telling us just a little bit about who you are and who SEPCO is, and anything that you think would be useful for folks to know.
Sure. Yeah. So I am the plastics sales specialist with SEPCO. SEPCO as a whole specializes in fluid and power sealing products, air seals, mechanical seals, braided packing, including gorge GFO fiber packing. We also do machine thermoplastics, which is my specific area of interest. I've spent 20 years now ish, 6 to 8 or so with SEPCO. 20 years in the thermoplastic fluoropolymer industry. I think I still have several lifetimes more things to learn. But I'm excited. I'm excited to talk today about the future of plastics, the future of bioplastics. It's all interesting stuff.
Yeah, that's great. I agree, and hopefully our listeners will agree as well.
Yeah.
So, for any of our listeners or viewers who are unfamiliar, could you kind of introduce us to the topic very generally, like regarding biodegradable and bio-based thermoplastic alternatives before we get into kind of the deeper discussion of them?
Yeah, sure. So bioplastics or biodegradable plastics is really just a kind of a branch of plastics that is bio-based, right? So when we think about bio-based, we're thinking about naturally based products as opposed to petroleum or other chemical-based materials. So these are any plastics, kind of broadly speaking, any plastic that has a biodegradable or natural feedstock. So these are corn, sugars, those kinds of things, plastics derived from those materials.
So then, what are some reasons why bio-based thermoplastics are kind of an important area of study and product development?
Yeah, that's a good question. It's an important one, I think, because for a couple of reasons. Environmental sustainability is probably like the biggest, I don't know, maybe the first reason. So bio-based plastics are derived from renewable resources. So things like sugarcane, corn, really plant-based materials. So we can grow our input materials. So any material required to create these plastics, we can grow it. So this is sustainable over longer periods of time. It helps reduce negative impacts to the environment that potentially is associated with other, kind of traditional petrochemical plastics. Um, it reduces greenhouse gas emissions, it reduces depletion of finite resources that will eventually run out. I know we have a lot of them, right? We have a lot of natural resources, but they're not endless. I mean, eventually we're going to run out. So looking for ways to create feedstocks that we can grow, it's a positive thing. The other aspect of it, why I think it's important, is that it allows kind of, I'll say, nature research, right? So it gives scientists an opportunity to study nature in an attempt to replicate like the amazing qualities that we find in nature. So things like the way a fruit grows skin to protect itself against the heat, like the volatile compounds that are found in plants that fend off insects, the way that plants grow and replicate and heal themselves. Like these are incredibly important and interesting properties that we should learn about. We should desire to replicate, if at all possible. And I give a quick example. 1928. It's a familiar story, but I'll give it to you. 1928, Dr. Alexander Fleming left a bacteria sample in a petri dish. He observed after some time that mold began to grow in the petri dish. As the story goes, I think he went out on vacation and went out of town for a while. When he came back, he noticed that the mold was preventing the bacteria from growing. Essentially, this mold was creating a chemical that was killing the bacteria. So mold growing in a petri dish created its own chemical that was killing bacteria, right? And that's just wild how crazy nature is. So as we know, he named that chemical that was created penicillin, and millions of lives have been saved as a result of Dr. Fleming and the discovery of something that nature did like, all by itself. So there's a lot of upside, I think. That doesn't just apply to medicine, although of course medicine relies a lot on what we find in nature. But in the industrial kind of bioplastic space, I think grounding our material science in natural science, it's important, right? I mean, we can learn so much, and there's so many interesting things to learn. So yeah, those are the reasons. Only two of the reasons why I think it's interesting and important.
Absolutely. So we already talked a little bit about some examples of bioplastics, but can you tell us a little bit about kind of how they're made and things like that?
Yeah. So they're I think all bioplastics, and again, I'm far from a bioplastics expert, right? So I'm talking kind of more in generalities. I don't know if that's right.
That sounds right.
Typically, they're all made from, again, some kind of natural feedstock. So corn, sugar, or just some of the most common examples. And some process breaks down those feedstocks into things like glucose, and then through a fermentation process, very similar to how alcohol and beer are made. It's the same microorganisms fermenting glucose, producing things like lactic acid. That lactic acid is a monomer that is then polymerized and produces, in the case of lactic acid, it produces the plastic PLA, which people might not realize that PLA is really it's probably the most common plastic that we don't really know about or that we don't think about, or most common bioplastic that we don't think about, because PLA is what's most typically used for 3D printing. So anybody who has a 3D printer almost certainly uses PLA, and that is polylactic acid, which is it's a bioplastic. It is, as I kind of just described there. It's usually I think it's usually corn, but probably sugar cane as well. Fermented and produce lactic acid, and then polymerized, and it makes a plastic. So yeah, that's probably that's one of the more common ones, but that's essentially how the process works. So there's other I don't know, kind of consumer plastics like PBS, which again is it's microorganisms. In that case, it's succinic acid that's then polymerized and formed into a polymer. So that's more or less how the process works. So yeah, it's very interesting. Yeah, it's pretty cool. It's pretty
Yeah,
cool.
it sounds very, very cool. And now for a quick word from our sponsors. This episode of the Pumps and Systems podcast is brought to you by SEPCO. SEPCO has been a leading provider of quality products and exceptional service for over 40 years, but we're more than just a provider, we're your partner. Our products range from mechanical seals to compression packing, graphite items, and gasketing materials. Additionally, we offer specialized items like die-formed packing rings, molded PTFE parts, thermal management solutions, and fiberglass products. Find your sealing solution today at sepco.com. All right, so we talked about how some bioplastics are made. So let's talk about what about like bioplastics for industrial markets?
Yeah, good. So there are some. So there is a common industrial plastic, PET, which is used in a variety of applications, including industrial applications like vertical turbine pumps and those kind of things. So there is a material called PEF, which is polyethylene furanoate. I think I said that right. Yeah, so it's a bio-based form of PET. So it's made from plant sugars. Same kind of process that I just described, fermenting those sugars, polymerizing them with ethylene glycol and PEF, right? Polyethylene furanoate is produced. So the reason why we would say that's an industrial application is because it's used in electronics. PEF, much like PET, it's kind of non-bio-based counterpart, is really resistant to moisture and some chemicals. So it's a good option for some electronic applications, protective coatings, encapsulating electronics. So it's used there, and then it's all used now in some beverage bottles. So probably some water bottles that you're getting, potentially some soft drink bottles, probably carbonated drinks more, and even probably alcohol is bottled in PEF now. So it helps extend shelf life of its contents because it does prevent gas permeation, similar to glass and other products. But again, that we're talking about now a biodegradable plastic. And so there's a handful of others. Polyglycolic acid. It's used in medical sutures now. Again, bio-based polymer, medical sutures, biodegradable plastic materials. There's also various starch-based plastics, often blended with other biopolymers to kind of enhance its properties. And again, that's things like packaging films, packaging containers, other disposable products, even like agricultural applications. I read like greenhouse films, like the film that covers greenhouses is now using PGA, this polyglycolic acid, and some other starch-based plastics. And even like if you go in irrigation tubing and you buy those like at-home irrigation systems for like your gardens and stuff, this is also a starch-based plastic now. So yeah, so those are some consumer kind of industrial applications. I think the main kind of hurdle with bioplastics coming into like a more like suitable industrial cases is their chemical resistance and their thermal and temperature resistance. It's kind of the main holdback, because right now in the industrial space, like fluoropolymers is king, and fluoropolymers are uniquely capable of covering this wide, broad range of chemical resistance. They're capable of covering a wide range of thermal temperature resistance from cryogenic to high temperatures. So you have like kind of a limited number of fluoropolymers that cover this gigantic range of industrial uses, and the bioplastics they're just not there yet. So will they be? Hopefully, people are working on it. And yeah, I think, and I believe in people. I believe in how smart people are and how intelligent people are. And they're gonna definitely gonna figure something out. I have no doubt they're gonna figure something out. So
I agree, and I hope so. But
yeah.
well, that does lead us into our next question, which do you think we will ever get to 100% bioplastic usage?
Yeah. Oh, no, right. And I don't think we ever will, for probably for a couple of reasons. Well, I'll say this too. I don't think we want to.
Mm,
Um, Primarily because of the idea of what we're using as the feedstock into bioplastic. It's primarily a food product, right? And so we're talking about corn or sugar cane or something like that. Um, so there's kind of some ethical issues I think that we have to tackle with the fact that if you're using, right, in our urgency to move to bioplastics, if we're consuming all of our food products for plastic containers and renewable plastics, what are we doing to the food supply? Like, so if people are going hungry because we're pushing for bioplastics, I don't think we've been super helpful there, So I think one of the issues why we'll never get to 100% bioplastic usage is the amount of input food that it would take to get to that point. Um, I'm not sure. I'm not sure we can sustain that. So, and I think secondarily, there's just a lot of really harsh man-made products that were in use right now. A lot of chemicals, a lot of bleaches, a lot of things that, a lot of refined chemicals, I guess, that natural products are just probably not going to ever fully deal with. So, will we ever get away from some of those harsh products? Maybe, but until we do, um, yeah, bioplastics just aren't gonna sustain that. So will we ever get to? Probably not. And I don't think we want to because of that. I think what I mentioned, like we want to feed people, So looking, kind of looking long term, we don't want to sacrifice, you know, present humanity on the basis of maybe potentially at some point creating, a more, biosustainable future. So there's some ethical things I think we gotta look at there. But all that to say, there's a lot of promise, and I think it's important to start, continuing to move in that direction.
yeah, absolutely. Okay. So then what do you think is the best case scenario for the thermoplastic industry kind of in the long term?
Yeah. So kind of looking out long term, I think probably a few different points here. One is that um, we kind of have a mindset shift within kind of the industrial sealing space, I guess, kind of fully embracing this idea of a circular economy, a circular system where materials are designed and produced and managed with the thought process of like minimizing material waste and environmental impact, which is not something that we really care about necessarily in the industrial space right now. What often happens is that we're looking to get things cheaper, which means things don't last quite as long, which means we're having to produce more of them. So we're not thinking about things kind of in that long-term, minimizing waste and environmental impact kind of mindset, right?
Mhm.
So I think shifting our focus to minimizing waste by making better products, right? That last longer,
Mm,
making things that maybe cost twice as much but last twice as long, right? This is kind of a mindset shift that we need, and I think bioplastics maybe can help kind of push that mindset shift.
mm,
Um, and so renewable materials, like continuing to push the idea of renewable materials. Like I think long term, the industry will shift towards bio-based as a result of necessity, and a lot of times it's outside pressure, some good, some bad, that kind of push this this shift towards renewable materials. So, and I think that's a good thing. Long term, we reduce our need for fossil fuels, reduce our dependency upon that, and move towards a bio-based alternatives. Like when that's kind of more widely adopted, I think we'll be in a better place. And then the other thing is like advancing recycle. I would say I'll call it recycling technology, I guess. There was a guy who spoke. I think I can mention his name. If I can't mention his name, you can cut this out. But I think I can. There was a guy who spoke at a VMA presentation, a VMA conference. That's the Valve Manufacturers Association. Not too long ago. His name was David Yankovitz. And he gave a presentation on recycling technology and all of the new innovations that are being made with recycling technology. And one of the things that he presented and demonstrated was that they're now able to recycle chemicals, not just mechanically recycle them, like how glass and plastic is kind of recycled now, where you just grind it up and reuse it. But they're actually breaking down the plastic back down to its original constituents. So like breaking it back down to the original monomers, and then they can reuse it there. So as that technology kind of advances, we'll be able to actually recycle some of these thermoplastics even in such a way that we're not having to create more and more. We can just actually put them back down to the original chemical makeup and then reuse them. So, and then I think the maybe the last thing, and I'm looking at the long-term aspect of it, is I hope that we continue to incentivize innovation, right, as opposed to regulating innovation. We're seeing it's a kind of a big thing now within the thermoplastic fluoropolymer industry, with the whole governmental regulations over PFAS. A lot of potential regulations, potential penalties that are kind of on the horizon. And I think what happens is that when we look at these kind of governmental regulation things, it generally discourages innovation. Incentivizing innovation, incentivizing companies and individuals who develop these products, who reward innovation, as opposed to kind of regulating everything to death as somewhat of a knee-jerk reaction, even at times. I think we're better off there, right? And often a carrot is a better motivation than a stick, right? Nice. So most of the time. So I think, so like long term, when we're thinking about long term, I hope that we offer, like the industry, governmental, all these organizations offer, incentivize this innovation, as opposed to trying to regulate everything else out of existence. Because I think the smart people that are out there, they need incentives to innovate, and when they do, we'll get the products that we're really hoping for, and that we all need, frankly. So that's bioplastics, man.
Excellent. All right. Yeah. So then essentially it's going to be like a lot of different things coming together to kind of move us in the right direction, rather than just bioplastics or just recycling techniques or things like that.
Yeah. There's obviously a lot of things that need to happen, which is why this is it's a long-term process, as with anything. So I get the knee-jerk reaction at sometimes, and rightfully so. There have been some pretty egregious mistakes made by the fluoropolymer industry and some of these big companies. But that knee-jerk reaction of not allowing innovation to kind of take place, it's just going to make things worse. It is. So it's going to take some time, but again, we need to learn from our mistakes and continue to innovate. And I think bioplastics is certainly one of those areas where that's possible.
Yeah, well, thank you so much for sharing your expertise with us on this topic.
Yeah, yeah. Thank you for having me again. Yeah, it was great.
Do you have any closing remarks or anything you want to say before we close off this episode?
Man, I think I talked probably too much.
No, on a podcast, I don't think there's such a thing as talking too much, but
Yeah, maybe not. Maybe not. No, I don't. I mean, I guess in general, I'm very passionate about the world of plastics, thermoplastics, fluoropolymers, certainly. Um, so for me, the idea of bioplastics is particularly important.
Mhm.
um, but I think as a whole, anybody who cares about the industry that they're in is going to embrace innovation, going to desire to see things change and grow and get better, not try to hold things back and keep things kind of where they were. So yeah, I'm fully embracing the bioplastic revolution. I hope that it works. I hope that we can continue to innovate. And I mean, who doesn't desire for sealing technology to be safer, better, more sustainable, renewable? I mean, who doesn't desire who doesn't desire all those things? So I fully embrace it and hope I live to see the day when it's it's all here, you know.
All right. Well, those are excellent closing remarks. Thank you again so much for being with us. And yeah, I haven't thought about a good way to end this. So just stop there and figure it out later. Huge thanks to Cody Kaufmann for sharing his expertise with us on bioplastics. And very big thanks to SEPCO for sponsoring this episode of the Pumps and Systems podcast. Okay, that'll about do it for today. Thank you so much for listening or for watching if you are watching on our YouTube page. I'm Tom Bear, and I will see you next time.